Alright, so previously we actually stopped at this point. We say that we read the data and then we print the data. After that, we read the next data and then we print the next data. Alright, if you are dealing with very small values or very small numbers of data, you can actually do that. But if you are dealing with a lot of data, alright, then you're gonna be very slow. Alright, you're gonna print in a very slow rate. Alright, why do I say so? Instead of following what the book has read as the baud rate of using 115200, alright, let us talk about if you were to have a baud rate of about 9600. Alright, more realistically lah. Alright, for Uno normally we use 0 dot begin 9600. Alright, and therefore if you still remember your button bounce, alright, your button bounce is actually it takes up about 50 milliseconds in order to go into to settle down. Okay, so it takes about 15 milliseconds to actually settle down. Alright, so before the settle down means that before it goes towards stability. Alright, before it actually you see, before it actually goes to 0 lah. I already went directly. But anyway, so this is 15 milliseconds for this thing to cool down. If you were to compare to a 9600 beats per second, for example, alright, 1 beat, alright, takes about so imagine you have a 12-bit numbers, alright, a 12-bit number is 12 bit divided by 9600 bit per second. Okay, so for example, if I were to use this thing, bit divided by bit per second, right, what I will have is actually bit times second over bit. So cancel, you have seconds. Alright, so over here in the end we should get something seconds. Okay, so 12 divided by 9600 is actually about 0.00125, or you can say it's about 1.25 millisecond. Okay, so for a 12-bit number, alright, because in terms of a number, normally they write in terms of a bit or whatever. Alright, because if you still remember back in our previous videos on unsigned integer and signed integer, you know that integers values are represented by binaries number. Alright, I will not go into details. If you are keen to look at it, you can go to these videos to check it out. Or in terms of the binary numbers that they take in. Alright, so if you talk about normally numbers take in about a 12-bit. Alright, so therefore if one number takes about 1.25, if you have 1000 data, alright, if you have 1000 data, then you're going to talk about taking 0.00125, sorry, so if I will be taking 1.25 seconds to load 1000 data. Alright, so I'll take about 1.25 lagging time to actually load 1000 data. If I have 10,000 data, I'm gonna take 12.5 seconds. Alright, this is 1.2, or you can say that, okay, for example, for 12-bit data, for example, 12-bit is equals to 1 data, or some data that you collected from analog. So it's about 0.00125. Alright, so if I have 1000, I'll just simply multiply by 1000. Alright, so it's 1, 2, 3. I have about 1.25 seconds, right? I take 1.25 seconds to read, to print, alright, to print the data about 1000 data. Alright, so 12, you take about 0.00125 seconds to actually print a 12-bit data. Okay, so a 12-bit data, a 12 bits is, okay, we say that if normally a one data, no, okay, we say that normally a number is about 12 bit, so one number is considered one data. So if I have 1000 data, then I will take 1.25 seconds. So if I have 10,000 data, then I'll take 12.5 seconds. So you see, I'm taking more and more times if my data is getting more and more, and this is really slow and not very efficient. Okay, so therefore if you were to extend to this, alright, although you have a bit rate per second of 115200 is pretty fast, but if you talk about a lot of data, this is actually quite slow, alright, comparatively. Okay, So therefore, what can we do about this? And therefore, am I recording now? Wait, yeah, I'm recording. Okay. So we need, therefore, we need a way to actually store a lot of data. Alright, because when you one shot print, if you one shot want to print, alright, this is, so we need at least 2 bytes for a 12-bit number in order to print the 12-bit number. So therefore, if you have a lot of numbers, a lot of bits that you require, you take a lot of time, right? So therefore, in order to, because normally the problem lies with printing, alright? It takes time to print out your serial dot print, alright? And if you have 10,000 numbers, you're going to serial dot print taking a lot of time, okay? So therefore, in order to cut short the time, what we can do is actually to initialize reading 1, alright, as equals to this thing. So we are trying to store a data, alright. So we store, we say that reading 1 is equals to you read the first data, and then you store it inside reading 1, and then you read the second data, you store inside reading 2, you store the third data, you store inside, you read the third data, you store inside reading 3, and so on and so forth, alright. And therefore this, although this can help in solving the problem, but you're gonna type in a lot of lines. You see there's so many lines, if you have 1000, you're gonna type 1000 lines, you siao, right? So therefore what we can do is actually to write integer readings 1000. So over here this 1000 tells you that you're gonna create an array of 1000 integer. Alright, so you don't need to write so many lines already. Alright, so this is one of the first step in creating an array. So you store your information in an array. Alright, and therefore this initialize readings 1000 help us to save the step in writing these steps. Alright, this initialize reading 1, 2, 3, but it doesn't help us to solve reading 1. It doesn't help us to solve reading 1 or 2 is equals to this. As you can see the next line, alright, initialize reading 1000, alright, it helps us to solve to cut down the process of writing initialize reading 1, initialize reading 2, initialize reading 3, but it does not help us to cut down reading 1 is equals to analog reading 2 is equals to. So in this case we are still gonna have 1000 lines. We're still gonna write a lot of lines, alright, which is also a problem. Okay, so in other words, if you don't understand over here, this is just trying that if you read at data 0, alright, this is equals to, so when you read a first number, you store inside as reading 0. If you read the second number or whatever, you store inside it's 20. So if you read the 23rd numbers, you store inside the 23. If you read the 24th, I should say, if you read the 24th number, you store inside the 23, because we start from 0, right? So I'll leave you to think about it. So therefore, these are the little things. So if you read 1000 values, the 1000th value, you will store inside the reading 999. Alright, but however, you need to type in 1000 lines, which is very, very not cool, right? And your program will most likely to crash, alright, due to array index out of bound. Alright, this normally they write as an error. Okay, so this is something that you need to take note of. And what if, so therefore you don't do this, alright, don't do this. So we, in order to rectify this problem, we can use a for loop. So we replace this system, alright, as this for loop system. If you still remember your for loop, alright, so you set your for loop. This is where you start. You set your integer index is equals to 0. This is where you start. This is when your objective. Alright, so if your index is lesser than 1000, alright, then you continue to loop. Alright, you continue to for loop it. Alright, and this is the process, alright, in reaching your objective. Alright, so if you still remember, index is equals to index plus 1, so you keep on adding and adding and adding until you reach 1000. Alright, then you'll stop. Alright, and the loop will break, and then you'll get to have all your data stored. Alright, so this whole code over here, what I've been writing, alright, is to store your is to store your data, or you can say to store your analog data. Okay, but take note that your for loop, if you still remember, if you write any for loop, if, else, or whatever, alright, though over here you don't put any semicolon. Alright, please remember that, don't put any semicolon. Alright, and then so after that you open up the bracket and you type in your codes for your function. So you over here you read your index, and then you store whatever thing. Alright, so you store each of this into each of the index, and then you loop again, and then index is equals to index plus 1. So you keep on looping and looping and looping until you reach index is equals to 1000. Alright, so I hope this is pretty clear. However, this is still not a very elegant way yet, because 1000 is over here. Alright, if I want to store 2000 data, then do I need to change these numbers again? If I want to store 3000 data, do I have to keep on change these numbers? Alright, these numbers. Alright, so one way is that I can actually define, alright, I will just isn't hex or hashtag, I forget. I think it's hashtag. So hashtag define data points 1000. Alright, so you tell the data points that this is a special code. You define the data points as 1000. Alright, it's not telling you that your constant input data points is equals to 1000. You don't use this. Alright, so we are not actually initializing that data points is equals to 1000. We are just telling you that we have 1000 data points. Alright, if you are 2000, you just write as 2000. If you're 3000, 3000. Alright, so in this case we are 1000, so I'll just write as 1000. Alright, so you initialize your reading as data points. Alright, and then over here your index, instead of writing 1000, you write as data points also. Alright, comparatively, as you can see, it's easier, so you don't need to change every time you change your number of data that you want. Alright, so therefore this is a very good method to actually define your number of data points. And therefore this whole thing over here is trying to actually store data. Alright, what we are doing is only store data. We say that we define 1000 data points that we want to store. Okay, then after that you use a for loop, alright, to actually store your data one by one. Alright, and that's all for storing your data. But however, you haven't print yet. Alright, so therefore we want to print everything together. Alright, you may wonder why do we store everything first and then we print? Because if let's say you read the data, so you read the data, you print the data, this will take in a lot of time. Alright, once you read and then you print and then you read again and then you print again, you are taking in a lot of time. Alright, so therefore what they do is actually to read everything first, alright, and then they print all together at once. Alright, at least it takes lesser time. Alright, so you may wonder, just now I say that if you were to print all short, alright, you're gonna take a lot of time. If you print 10,000 data, then you're gonna take 12.5 seconds. Alright, and I am partially right. It's because if I were to print 10,000 data, this also say that I'm going to read and print 10,000 data together. Alright, read and print, we're going to take a lot of time. Okay, well, if I were to read everything first, then I print, then it's a different story. Alright, I'm gonna cut down the number of time taken. Alright, so what we're doing is actually to read all the data first, and then we print all the data. Okay, so this is how it actually is being implemented. Alright, so this is something that you also need to understand. Alright, so therefore over here we are starting to print our thing. So we'll use 0.println, means that once you type in the first line, you'll start a new line, and then you print finish a new line, you'll start another new line, if you keep on having a 0.println, right? So same thing, you're going to use your for loop again. You start with the index equals to 0. This is your objective, your number of data points, and this is your processes. Alright, index plus 1 is equals to index. Alright, without any semicolon, still remember. Alright, and 0.println reading index integer. Alright, so you're gonna print line, and you're gonna print your reading from your index. Alright, so you're gonna print your reading from your index. Alright, and it is in terms of an integer. Alright, so integer is a number, okay, so to speak lah. Okay, if you were to print in terms of a float, then you're going to take more time. If you still remember, the float is actually taking a lot of time. Nonetheless, you can also print unsigned integer, I think. I don't know, I'll leave you to think about it. Alright, these are all. So if you talk about integer, everything you talk about chapter 7, alright, all about this binary numbers and things like that. You can actually take a few of the time to read if you need this information. And therefore altogether this will actually print a list of data, and once you print the list of data, you can copy and then you paste inside your Excel and you're ready to plot. Alright. And last but not least, alright, you can actually have a refinement, alright, where we capture the data using the analog read. You can also read how fast the analog is being captured, alright, by using macros function. Alright, we could also save the time. It's not tell you that you save time, alright, it's not telling you that you save time, alright, it's telling you that you save the time taken to read the analog. So it's a two different things, so be very careful. I took quite a while to actually understand what they're trying to say. Alright, so the macros function is to help you to read the time required require for your analog read. Alright, so you can actually write at the, so for example, if this is the store data, right, you can actually write at this point, alright, before you close, so the bracket is over here now, so over here I write macros bracket. Alright, so over here this function will actually help me to also feedback how fast I read the analog data. Alright, so this is one method to actually read the time taken to actually read your data. Alright, so this is how actually they work lah. Which this returns the number of microseconds since the SAM was powered up. So once your Arduino is powered up, alright, you'll start to count in microsecond. Alright, you start to count by 1 microsecond, alright, it's 2 microsecond, you'll keep on counting about to approximately 70 minutes. Alright, that's what the Arduino has said. Alright, where am I? So after approximately 70 minutes, alright, you'll go back to 0. So you actually restart and continue to count again. Alright, so that your Duo and your Nano has a resolution of 4 microseconds lah. Alright, and on your Arduino, on others is 8 megahertz or whatever, I don't know, I'll leave you to think about it. Therefore, if you're free, you can just do it inside your Arduino Uno, whatever. Alright, so this is the final thing lah. So you're gonna put your program all together. Alright, so the program that you're gonna put is to put this one over here. Maybe I should print screen. So if I were to put it in full, this is how the code will look like. Alright, and so first you define your data points. You say that you want to take in 1000 data. Alright, and then after that you initialize your reading with the data points that you want. Alright, so over this section over here, this is one of the for loop. So this for loop over here is used to store your data. So for whatever index that you want, alright, index is this, so this is your starting point, this is your objective. So if your index reaches your data points, alright, then you'll break the loop and you'll continue, so you'll start to print. Alright, so this is the process of reaching from your starting point to your ending point objective. So this is the bridge, as I said earlier. Alright, and over here once you read all the data, every data, so one data you read, you store it in one index, and then after that you print the micro time that you take for this one index 1, and then after that you store it inside some places or some storeroom. Then the second data comes in, alright, you store inside the second index, because index is equals to index plus 1. So previously it was 1 plus 1 is now is equals to 2. So you take in the second data, and then after that you store inside again. Alright, the macros itself is to read, alright, the time taken for in order for your analog to read. So the macro is actually to read the time that how fast can your microcontroller take to actually read your analog signal. So macros is the purpose of this is to read how much time is needed to actually process the analog reading. Alright, so this is like a plus point lah, alright, just for you to take note of. Alright, And then after you settle everything, you store everything, then you can start to print. Alright, so over here you start another for loop. Alright, this new for loop is for printing. Alright, so previously was storing, now it's for printing. So you start off with your index, and then this is your objective, same thing, this is your processes. Alright, one index and one index, you keep on adding up until you reach your data points. Alright, which our data point is 1000, just to take note of the hashtag define lah. Okay, so over here you're gonna print your reading index. So you're gonna print one of the index by one of the index. So you print the first index, alright, and then you print the first micro index also. Once you print finish, alright, then you loop. So this thing over here, your 1 plus 1 is equals to 2. Alright, so over here this is the first index, right? So actually the first index is 0, but anyway, so 1 plus 1 is equals to 2, just for your understanding. So over here they will tell you to actually print reading index 2, reading 2, micro 2. So you'll print the next one. Alright, so after that, then next one, your index will becomes 2, then it becomes, so 2 plus 1 is equals to 3. So over here you'll print the third number and the third time taken to read your analog signal. So you'll print it out again, and then you'll loop back again, and then you'll keep on loop until you reach your data points, which is 999. You cannot reach 1000. 1000 means that you break the loop, because this 999 is the value smaller than your 1000. Alright, if you reach 1000, alright, then you'll break the loop, because you must be smaller than 1000. Okay, so therefore this is it. Alright, and you may wonder, if 1000 over here, then why is my value 999? Alright, because you're starting from 0 to 999. So 0 itself is already a 1 value. Alright, so in this case, this 1 value plus 999 is actually equals to 1000. Okay, just think about it lah. Alright, because 0 to 999, for example, 0 to 5, how many numbers can I store? I will store 6 numbers, because 0, 1, 2, 3, 4, 5, 6. Actually, yeah, so this is, sorry, I'll store I'll store 6 numbers from 0 to 5, right? So I'll store 6 numbers. This is the first number, the second number, the third number, the fourth number, the fifth number, the sixth number. So from 0 to 5, I store 6 numbers. Alright, so it's like a plus 1, you see. So therefore over here, from 0 to 999, I actually store 1000 numbers, which is the plus 1. If you don't understand, you can just click back a few minutes ago, and then you just recap. Alright, it's pretty straightforward. Alright, and this is it for array stuff. Alright, so see you there.